Hello everyone, welcome to my YouTube channel Rich Brain. In today's video, we are going to find solution to the calculus question on the board, which says that we should evaluate the integral of sine exponent 4x ds. So come as we find solution to this. Remember, from double angle, that's cos 2x is equal to cos square x minus sine square x, and this came from compound angle. Also, cos square x plus sine square x is equal to 1 from trig identities. So making cos square x the subject, you can say cos square x is equal to 1 minus sine square x. So now we can substitute this in place of cos square x and say that our cos 2x is equal to 1 minus sine square x, then minus sine square x. So our cos 2x will be equal to 1, then minus sine square x minus sine square will be minus 2 sine square x. So we can make sine square x the subject and say that 2 sine square x is equal to 1 minus cos 2x. That's I brought this here and I send that one there. So dividing both sides by 2, you can say our sine square x is equal to 1 minus cos 2x all over 2. Also, from this our identity, sine square plus cos square, if you want, we decided to make sine square as a subject, then we can say that our sine square x is equal to 1 minus cos square x. So substituting this into this double angle, our cos 2x will be equal to cos square x, then minus, in place of sine square x, we substitute 1 minus cos square x. So we say 1 minus cos square x. So our cos 2x will be equal to cos square x minus 1 plus cos square x. So our cos 2x is equal to cos square x plus cos square x will be 2 cos square x, then minus 1. So we want to make cos square x the subject in terms of cos 2x. So we'll say that we'll bring our 1 here. So we say our 2 cos square x is equal to 1 plus cos 2x. Dividing both sides by 2, our cos square x is equal to 1 plus cos 2x all over 2. So if cos square x is equal to 1 plus cos 2x all over 2, then we can say our cos square 2x will be equal to 1 plus cos 4x all over 2. So this identity and this will help us find solution to our problem. So from our problem, the sine exponent 4x can be rewritten as sine square x all square. And what is our sine square x? Our sine square x is this. So we can say our sine exponent 4x is equal to 1 minus cos 2x over 2. That's in place of sine square x, I'll substitute this all square, which will be sine exponent 4x is equal to 1 minus cos 2x square over 4. That's 2 square is 4. Then I can expand this and say that sine exponent 4x is equal to 1 minus cos 2x, since it is a repeated square, then 1 minus cos 2x, and that all over 4. So our sine exponent 4x will be equal to, so when we expand it, this times this will be 1, this times that will be minus cos 2x, then this will be minus cos 2x, then this times this will be plus cos square 2x, and this over 4. So our sine exponent 4x will be equal to 1 minus cos 2x will be minus 2 cos 2x plus cos square 2x, and this all over 4. So our problem, which is the integral of x exponent 4x dx, will be now equal to the integral. So in place of x exponent 4x, we put that. We have 1 minus 2 cos 2x plus cos square 2x, and this all over 4 dx. So now, since this is a fraction, which is 1 over 4, I can pull it out. So I'll have 1 over 4, the integral of 1 minus 2 cos 2x, then plus cos square 2x dx. So I can split this my question as 1 over 4, the integral of 1 dx, minus 2, the integral of cos 2x dx, then plus the integral of cos square 2x dx. But remember, our cos square 2x is this identity here. So in place of cos square 2x, I'll substitute this. So I'll have this to be equal to 1 over 4, the integral of 1 dx, minus 2, the integral of cos 2x dx, then plus the integral of 1 plus cos 4x all over 2 dx. So this can also be rewritten. So we have 1 over 4. I want to get everything right before we start integrating. 1 dx minus 2, the integral of cos 2x dx, then plus, I'll bring the half out and get integral of 1 plus cos 4x dx. So now I'll integrate now. So I have 1 over 4. The integral of 1 will just be x. Then minus 2. How do we integrate this? We integrate cos. When we integrate cos, we get sine. We repeat the angle and differentiate this. When we differentiate 2x, we'll get 2 and use it to divide. I hope you get that. Then plus half. The integral of 1 will be x. Then plus the integral of cos 4x, the same thing. We integrate cos, we get sine. So sine, repeat the angle, differentiate 4x, we get 4 and use it to divide. Then plus our constant of integration. So in polishing this, we have 1 over 4 x. These two divide that, we'll be left with minus sine 2x. Then plus, we expand this. This times this will be half x. Then this times that will be plus sine 4x all over it. Then plus our constant of integration. So now you can use the 1 over 4 to multiply everything. So 1/4 times this will give us 1/4 x. Then 1/4 times this will be minus sine 2x over 4. 1/4 times that will be plus 1 over 8x. Then plus 1/4 times this will be sine exponent 4x all over 32. Then plus our constant of integration. So we can add 1/4 x to 1/8 x. We'll get 3/8 x. Then minus our sine 2x over 4. Then plus sine 4x over 32. Then plus our constant of integration. Then we can say that the integral of sine exponent 4x dx is equal to 3 over 8x minus sine 2x over 4, then plus sine 4x over 32, then plus our constant of integration. I hope you get this right. Please, if this is your first time of watching me, consider subscribing to my YouTube channel, like and comment, because these are the only ways you can help promote my YouTube channel and I can record more mathematical content. Until we meet again, bye bye.